Hi, welcome back to Dad and Kids Coding.
Hello.
So today we're doing a little computer sciencey problem because what we're looking for is we're trying to find boarding passes, and boarding passes are coded in a very strange way called binary space partitioning. So rather than just being a zone or whatever, it's coded in this very strange way. So basically what this means is F means that it's in the front half of the plane, and then the back quarter of that half, and then the front eighth of that half, and the back 16th of that half, and the back 32nd of that 16th, and then the front 64th of that, and so on. So there are 128 rows on the plane. So the first 8 characters code that. And then for 7 characters, sorry, code that, the 128 rows. And then the last 3 are tell you the column or the seat within the row. And again, it's done in a strange way. So R means on the right hand side, right half, left quarter, right eighth. And then once we've got the row number and the seat number, we multiply the row times 8 and then add 5 to get the actual seat ID. So if we look at this carefully, what we'll notice is that if we just treated all of there are 8 columns, and we're supposed to multiply by 8. So really that just means if we treat all of this as the first half is already 8, if we were looking at this in binary, which is very computer sciencey, but it means base 2. So if we converted all the F's and L's to zeros and all the B's and R's to ones, then this would be a binary number. So let's just copy this and go over to our workspace and play with this a little bit. So we have the number or the string this. Now let's just play with this a little bit. So what I'm contending is that if we just look at this as 0, 1, 0, 1, 1, 0, 0, 1, 0, 1. In other words, all the F's are zeros, all the L's are zeros, and all the B's and R's are 1. If we did that, and then we added the way that we say that we want to look at this in base 2 in Smalltalk, which is we add 2R to the end, and then we ask for this as number.
Or the beginning, rather. 2R beginning.
2R at the beginning, yes. And we did ask for this as number, we get 357, which, not surprisingly, is the number that we wanted over here. Okay, so what we have to do is we have to basically take these boarding pass codes and translate all the characters. So that does the right thing. Whoops. Didn't mean to make it go away. But now we have to find a way to translate this. So what I want to do is I want to take my original string and I want to translate this. And which of these translations do we want? Well, let's try translate with and see how that works. Well, yeah, let's just look at that for the moment. And so let's open the definition of that. So translate with says translate using a table and translate the characters in the string by the given table in place. Okay, that sounds useful. let's find all the places that send this, because I don't know what table looks like. So let's go and see if we can find out what table looks like. So here are the senders of this. And they're translate to lowercase and translate to uppercase. Okay. So what does that mean? Well, this is lowercasing table. And if we look at the other one, it's uppercasing table. And what are these? Well, let's go to let's browse the class for a moment and see. If we look at the definition for string, we see that these are uppercasing table is here and lowercasing table is here. So these are what are called class variables, which are things that are typically defined on the class side of these and visible on both the class and the instance side. So let's go over to the class side and look at the variables that reference this. So here are these class variables, and let's look at lowercasing table, for example. So this is set up by a class method called initialize, which is called when the class is loaded, and it is going to initialize these tables. And here we see lowercasing table is the result of calling this method called new lowercasing table. So let's go back over to the method side and see. So we have these new lowercasing table and new. So basically what happens is, let's just look at what lowercasing table looks like. Well, let's just evaluate this and see. And we see that it's just a byte string, and it is 256 elements long. And so it is just the string with all the characters. And this is the lowercasing one that I'm looking at. And you see, so all these are just the ASCII characters in order. But notice these should be the uppercase characters and these are the lowercase characters. So what they've done is they've gone through and replaced all the uppercase characters with lowercases, so each of them gets translated using whatever characters here. So most of them are going to get translated exactly as they are, but the uppercase characters are going to get translated to lowercase. So let's just see what. So this is all the byte characters, just to see. So exactly the same thing. This would be a identity transformation. It wouldn't actually do anything because the uppercase are in uppercase and the lowercase are in lowercase and so on. So the trick we're doing is doing this special. We're building basically a new string that is going to be the translation. Now we could look around at several of these, but new tokenish is actually the one that's most useful to us because it tests to see, it goes through all the characters and makes a new string, checking to see if the character is, for example, tokenish. And if it is, then it puts that character itself, otherwise it does something else. So in other words, we can loop through all the characters, and if the character is one of the ones we care about, then we'll do something simple like this. We'll translate it, and otherwise we'll leave it the way it is. So I'm just going to copy this code because we're going to want this code somewhere. Okay, so that's kind of the preamble for this. So we have a way to build a token table or a translate table that we can then use with translate with. Okay. So let's go back to our tests. Now this time I could do this the way I have before and put things into the string or the array or whatever class. But I'm going to instead this time I'm actually going to put them in the Advent of Code class. So let's write our unit test first. Actually, I'm just going to go over here and in the initialize side, I'm going to create a new class method called initialize. Oops. And I'm just going to set, I'm going to make the boarding pass table be and something like this. So I want to take all the string with all these characters and I want to collect, but I want to do it slightly differently. So if the character is in, if L and R includes the character, oops, not L and R, if L and F, then we want to use 0, right?
Right.
If it's not, then if R and B B and R include the characters, then we want to, so if that's true, then we want to return a 1. Yeah. If false, we just want to return C itself. Okay, so that's the end of that if, the end of the if false, the end of the collect. Okay. So let's save this. Oops, missed something. Oh yes, we need the close parenthesis for the characters. Now it's saying boarding pass tables undefined. So what do I want to do? Oh, well, I want to make it a class variable, which means that I'm initializing it on the class side, but it'll be visible and available in the on the instance side. So I'm just going to execute that, and then let's look to see what this variable has in it now. And we see that it is the identity transformation, except that B has been translated to a 1, L is being translated to a 0, R is being translated to a 1, and F is translated to a 0. Okay, so that's exactly what we want. It's a translation table that's the identity except for those 4 characters which are going to be translated differently. Okay, so now let's go over and build our test. I just did this first because I already had that in my cut buffer, and so that was the convenient way to do that. So let's go over here and get our test data. So let's grab these. And so this is test day 5A. And we want to self-assert that AOC day 5A with this equals oh, and we're supposed to find the highest seed ID on a boarding pass. So the highest one here would be 820. Okay, and we just need to clean this up a little bit. So this is, I don't care about the, I could run these tests separately, but I don't think I need to do that. And at least I think this is what my data is going to look like. So let's just go back over and see what puzzle input is going to look like. And sure enough, it just is all these boarding pass names. So let's copy that.
A huge list of mouth noises.
Yes. Yes, indeed. So then we'll also say self-assert that AOC day 05A applied to this equals, and again we don't know what the correct answer is, so we'll say that equals nil. So let's go back over here and paste this in here. Okay. Now, so we've got two problems. One is we have this AOC value, which I haven't defined, and the other is the method. So let's save this. And I'm going to make AOC be an instance variable for the tests. Instance variable just means it's available in multiple places. So I'm going to start with setup, and here I'm going to put the code. So I'm going to say AOC is a advent of code 2020 new. So it's creating an instance of the advent of code tester. Okay, so let's go back to test day 5. It's all good. And so now let's try running it and see what happens. And not surprisingly, advent of code did not understand day 05. So we'll create that. And we're going to create it in advent of code 2020. Now I don't have to browse like I did before and put this into the advent of code because it's in the advent of code. So I don't have to mess with that. So what do I have? The string. So again, I'm going to do, so let's just do let's do a string lines. Let's just verify that that does the right thing. So inspect that, and it's the lines, okay, which is good. Okay, and actually, let's just go back to, let's save that for the moment. Go back to day 5, and I probably didn't want to put that first. Actually, I've got one more test to do. One more test data. Let's do this. The other test data was that first one that they gave us, which evaluated it to 357. So let's just copy that too, and add that to our test case as well. Nope. Yes. Okay. And proceed again. Except that I didn't put a stop in there, so it's going to, yeah, it didn't do everything. So, well, okay, let's restart and step into. Okay, so we're back into the code. So a string lines, now let's just verify it again. Okay, so it's got 4 lines. Oh, there could be some spaces at the beginning of the lines, okay. So then we should collect. So we're going to loop through all of these, and we're given a line. I need to process that line. Okay, So what do we want to do with that line? So I think I'm actually going to be able to do this all in one expression. So I'm going to assume that. So we're going to take the lines, and we're going to take the line, we want to trim the line. So line trim, and then we want to translate it with and we have this passport, oops, what's it called? I don't know what it's called, so let's just say nil for now, and we'll go over and edit the code in the browser. So in the browser, admin of code. Oh, boarding pass. I thought it was called password or something. Okay, that explains why I wasn't getting it right. So day 5. Okay, so translate with boarding pass table. Okay. And actually, before I do that, let's add the 2R to the beginning of it. Oops. So I'll take 2R appended to the trimmed line, and then I'll translate that whole thing with the boarding pass table. And then all of that I'll look at as a number. Okay, so why don't we see what that does? But I'm not in the middle of executing it, so let's just put a self-halt at the beginning. Save that, and then go back to here and run my test. So we halt there, and now let's just see what this looks like. So inspect that, and there we have our numbers. Each one is an integer, which is exactly what we want. And the only thing is now we're supposed to find the maximum value of this. So we should put all of this and ask for the max. So let's see if that worked. Inspect, and we get 820, which is what we wanted. Good. Okay, so we'll take out the halt. Save that and proceed. And the first one passed, and the second one says 965 is the proper answer. So let's fill that in here and fill it in here and submit. And we're right. Excellent.
Woo!
Another gold star. Okay, continue to part 2. Okay. Fastest seatbelt signs turn off. Time to find your seat. It's completely full flight, so your seat should be the only missing boarding pass on the list. However, there's a catch. Some of the seats at the very front and back of the plane don't exist on this aircraft, so they'll be missing from your list as well. Your seat wasn't at the very front or the back, though. The seats with IDs 1 and more, +1 and -1 from yours will be in the list. What is the ID of your seat? Okay, so now we need to do basically the same thing, except that when we get all of the list of IDs, we need to find one that has the ID +1 and ID -1. So let's see how we would go about this. So that's good. That was correct. So now we need day 5B. So, and ask for day 5B of this, and A5B. Okay, so the first one isn't going to work. There is no, this seat doesn't have, or this list doesn't have +1 and -1 in it. So, but this one does. So we're good. So now we'll just run day 5B on all of this. But we don't know what it's equal to. So we'll say nil again. Okay, save that. Okay, so now let's run that test. Okay, of course this didn't exist. So let's go and look at our code here, and we'll go back to the instance side and look at our day 5A. So this conversion of the string to a list of values, an array of values, is something we're going to want for both of these. So we could just copy this code and put it in a new method. So let's call it day 5 convert, and I'm just going to return this. So day 5 convert does all the conversions. I don't need the parentheses now. Does all the conversions and returns something, and then day 5A is just going to say self day 5 convert a string and then do the max of that. So let's just verify that our test works, because we just refactored, so we want to make sure that our test 5A still works. It does. So now we're ready to try test day 5B, which doesn't exist, so that's fine. We'll create it. Admin of Code 2020. Okay, so now we should implement this. So we have self day 05 convert string, and this is going to return a set of numbers. So let's see how we can. So there's a couple of ways we could do this. I'm going to write it as a as ordered list, as sorted list rather, sorry, sorted list, sorted collection. Okay, so we're going to make this as a sorted collection. And now let's see if we inspect this. So now all the numbers are in order. And somewhere in here there's a gap. Okay, so now we could
As with many things in life, brute force is an option.
Brute force is an option. So let's
but, you know, it's a programming thing. Let's oh, he's processing.
Yeah, thinking about what the best way to do this is, or the simplest and shortest way of doing this is. We could go through this list, keeping track of the previous number we've seen, and see if the next one is 2 more than it. And if it is, then we would have found the right answer, I think. So let's try that. So let's call it previous. And I'm going to say previous is initially, well, let's just make it a negative number -2 because we're sure that that would never, the previous one would never be there. So then let's just loop through these, do each, and if, so what we know is that when we come across a number, if the last one we saw was 2 before it, then the correct answer is 1 before it, because we're only missing one seed. So if previous plus 2 is equal to each, if true, then we should return each -1. I'm going to rewrite this so it's a little bit clearer what I'm doing here. So if each -2 is equal to previous, so if each -2 is previous, so I'm actually going to change this to -3 for no good reason.
Okay.
Well, for a reason, because 0 would be a possible answer, and then 0 -2 would be equal to previous, which wouldn't be the right answer. So making it move back a further one so there's no possibility of this ever being true on that first iteration. So if we find that this one -2 is equal to the previous one, then we want to return that. But we also need to say if false, then we should set previous to each, because this next time round will be the previous value. So let's save that and proceed, see if it works. And it returned a number, 524. That seems as plausible as anything. And so let's fill that in. And save that. And go over and try that. And it's the right answer.
Woohoo!
So now let's just commit the code in the repository, and then everything is good. So commit, and here are the changes. So the things that were added were df5 convert, and so on and so forth. We added an initialize to the class to set up the boarding pass translate table, and then we did the day 5 tests. What I didn't do this thing that I did consistently before, which is that I put all of this in my data. So I'm going to change this quickly and have this just return, call this data for day 5, and have this simply return this, and then go down to the bottom. Scroll, 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 and get rid of, no, go down the bottom. Thank you.
Slingshot it back up.
I don't know what that was about, but, and
Maybe a
get rid of
sticky,
this.
maybe a sticky cursor.
Possibly. Okay, so I did that. I'm just going to change my 2 tests here so that instead of doing it this long, ugly way, we say self data for day 5 instead. Okay, and let's do the same thing for, let's just verify that still works, yes. Do the same thing for day 5. That's a faster way to do that. Self data for day 5 equals that. Sure that test works. Data for day 5 should be in data, not tests. So tests are all the tests, data is all the data, and we're good. Okay, so let's go back over here and commit these again. Right, so we have data for day 5, setups, tests, everything looks good. So finished AOC day 5, 2
Stars.
And we commit.
Sure.
Okay, and again, we'll just check that when we reload here, we have 13 seconds to go. So, all good. Everything has been committed. So, thank you again for joining us in our Advent of Code day 5 for Dad and Kids Coding. We'll hope to see you tomorrow. Bye.
Bye.